Great.
All right. Alrighty then, let's get going.
Chris, I just wanted to make a short introduction of you.
Okay.
It's okay. Sorry.
That's all right.
Well, okay, folks. I'm now proud to introduce Chris Saxon as our keynote speaker. Chris works as a developer advocate for SQL at Oracle. He's active on social media as a speaker and on various blog channels, and is a proven expert in the use of SQL in the Oracle database. He also acts as a trainer and is a frequent answerer of questions on Ask Tom. We are now very much looking forward to his talk, Oracle Database 21c for Developers. Chris, I'm happy to hand over now to you.
Okay, that's great. All right, thanks, Pascal. All right, let's get going. And we're going to start off by talking about something really exciting. That's invoices. Okay, maybe not the most exciting thing in the world, but it is a really important topic, because ultimately it's by issuing invoices is how your company gets paid, which means how you get paid, right? And we all like getting paid. So there is a lot of complexity when it comes to creating invoices, reporting on them, and so on. And there's various features in 21c which can help make those processes a little bit quicker. And we'll see those as we go through the presentation. So as Pascal says, I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team and part of the answer team on Ask Tom. It's my job to get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. Now, before we get into the details, technical details, just some kind of admin things to start with. One of the first things some of you might be wondering is, where can I actually get a hold of 21c? So this was released earlier in the year on Oracle Cloud, and it's still only available on Oracle Cloud. So the on-premises release will be coming out sometime later this year. If you want to get access to it, the absolute best way is to sign up for an always free cloud account. So this gives you access to up to 2 autonomous databases, which you can create on 21c. So they are free for you to use and do whatever you want, subject to some usage restrictions, such as 20 gigs of data and so on. So that's the best place to go and try this out. The next kind of little admin thing is, some of you might have read the little tagline underneath and said, this is the latest innovation release. You might be like, well, what does that mean? What is an innovation release? Well, we now classify releases in 2 ways. They are either long-term or innovation. So 19c is the current long-term support release. So that means you've got many years of support available for it. 21c innovation releases only have 2 years worth of support. So if you upgrade to 21c, that means you are committing to upgrading within the next 2 years, right? Now, at this point, some of you are kind of might be scratching your head a bit and thinking, hang on, committing to upgrading within 2 years to stay supported, that's not a guarantee I can make. You know, it's a push to get our databases upgraded once every 5 years. Say we have to do it in 2 years, that's not going to happen, or I'm not prepared to make that statement. Now, this is where I'm going to get on my high horse a little bit and say, maybe you should use this as a spur to try and upgrade more frequently. You know, keeping your database patched and up to date is really important. And actually, this applies to your entire tech stack, not just Oracle database, but whatever middleware or any other databases you use, you should be aiming to upgrade them frequently. Why? Well, the more often you do something, the more comfortable and familiar you get with it. If you wait 5 years between upgrades, then it becomes a big, scary task, which becomes something you want to put off. And the more you put it off, the bigger and scarier it gets. So you should really be aiming to upgrade regularly. That said, I completely understand that some of you going, well, I've got 1,000, I've got like 1,000 databases. It takes me a whole year to go through and upgrade all of them. I just don't have the time. The business isn't going to give me the time to be able to upgrade these more frequently. And if that's the case, staying on 19c is a perfectly valid strategy. Upgrade your estate to 19c, but it is still worth evaluating what's in 21c. Why? Well, there is a lot of cool new features in 21c. And I think this is the best developer-focused release since I've joined Oracle, so the past 5 or 6 years now. And it may turn out there's 1 or 2 features in here you look at and you go, actually, that is worth upgrading this application for. So you might have your massive estate, which you generally want to aim to a 19C, but there might be 1 or 2 of them you go, actually, I see it is worth upgrading that specific database for that application to get it on the latest release, because that feature is worth it for us. And it's just one thing out of a huge backlog. So it is still worth knowing what's coming, so you can make that analysis and evaluate whether or not it is worth taking the time to do that. So with that in mind, let's get into it and start getting into more of the technical details. As I said, generating invoices can have a lot of complexity, and a big one is things like currency conversion. So you can see here we're issuing the invoice in dollars. So let's say that's the customer's currency, and you need to convert it into your business's currency, so Swiss francs, or the vice versa. And when you're creating the invoices, you want to do this conversion. Now, if you do this as a batch process or ongoing process, there might be large numbers of invoices you need to do this for. And so you'd rather not have to look up the exchange rate every single time for each new invoice that you process. So how can you avoid that? Well, you can cache the exchange rates. Just load them into an array and store the details there. If you're doing that in PLSQL, what we can do is create a table indexed by varchar2. So we're going to use is the currency code as the lookup value for that array. So CHF, GBP, EUR, that kind of thing. So we can use that to find what a particular exchange rate is. So we can do a conversion nice and simply like this. So we don't need to then query the table each time to find what they are. So that's great. But the question becomes, how do we actually initialize that array, right? How do we load the values into that array? And this is something that was a bit tricky to do in Oracle database, in PLSQL in particular in the past. You'd have to do something like this, cursor for loop, where you iterate through the items, and each iteration assign the value to that array item. So, you know, it works, but it's kind of a lot of code. Now, in 21C, there's a whole bunch of improvements which make this a lot simpler. First of which is qualified expressions. Now, this is actually something that was introduced in 18C. So if you've got your array types or record types, they now all have an implicit constructor. So if you declare the record type as whatever, they have that implicit constructor, which makes it nice and simple to initialize the values. Or at least it does if there's a small number of them, right? You know, if we've got 2 or 3 currencies we want to load here, you could probably write them out individually doing something like this. But when you've got an unknown number of currencies or a large number of them, it's just not practical to do something like this. So we've expanded qualified expressions a little bit further. And before I show you how to load this array, I'll just take a slight sidestep to show how the new initialization process works. So rather than just specifying the individual indices, what we now can use is a for loop to specify what the indices, the index values for that array is. So what we're doing here is we're saying we're indexing from the values 1 to 10, and for each one of those, the value of it is just going to be that value. So we're going to have 1, 1, 2, 2, 3, 3, that kind of thing. So far straightforward, but not really very interesting, right? So, you know, we could do this with bulk collect. There is an extension to this. We can specify an expression for a custom index. So rather than using values 1, 2, 3, 4, and so on, we can double them. So we can say here that the indices are now 2, 4, 6, 8, 10, and so on and so forth. And the value for that index is going to be half of it. So first entry is index 2, and its value is 1. Next one is index 4, its value is 2, and so on and so forth. So this is nice, but how does it help us load our currency array in like this? Well, not only can we use like a traditional for loop, you can also use a cursor for loop here and use columns from that as the index. So we can declare our cursor, declare a row type based on it, and so on and so forth. and then initialize the whole thing with this. So nice little simplification feature, makes it easier to do these kind of initializations. But there's still some challenges here, right? We've loaded the data into the array. We probably want, for debugging purposes or whatever, to see what's in there. So the question is, how do we iterate through it? How do we see what all the values are? And this, again, is something that was a little bit fiddly, a bit of a pain in traditionally. So you'd have to do a while loop like this. So if you had a index by varchar2 or just a sparsely populated array in general, you'd have to do something a little bit like this. And it's something I always need to double check how to write it. And, you know, there's a trap, you can end up with infinite loops and so on and so forth. It'd be nice if there was an easier way. Well, this is where the new looping improvements come in. So rather than having to write that while loop, we can actually use the array as the driving values for the index. So you can see here for indices of, so that means, you know, GBP, CHF, EUR, that kind of thing. Those are the index values. We can also do for values in. So if you're familiar with for all, which has the indices of and values of clauses, very, very similar. But there's also another little extension here. We can also have this pairs of syntax. So notice I've now got two index variables. That's interesting, right? The first of those is the array indices. So GBP, CHF, EUR, so on and so forth. And the second one are the values that correspond to that index position. So we can then simplify our code even further. Instead of having to say, you know, corrects what the index is and then its values, we can just specify the values directly. Again, another little simplification feature. And this is something that seems like, it may not seem like a big feature, but I promise you, once you start using this and start getting used to it, it's very, very hard to go back to the old way of having to write while loops, right? So it seems simple, but it does make your life an awful lot easier if you work with arrays regularly. And you know, I've talked about array iterators and loop constructors, but these really are just the tip of the iceberg for the improvements to these iterators and qualifying expressions. There is a whole stack of other improvements to these. They may seem a bit crazy at first, but like I say, once you get used to them, they make a really big difference and make your code much more concise and easier to write. All right, then. Let's move on. We can generate our invoices. Let's say we want to do some reporting on that. And you've been asked to show all the expensive invoice items. And in order to do that, we probably need a calculation a bit like this, because rather than storing the total, you just store the unit price and the quantity. And then we might need to do exchange rate conversions as well. So it seems pretty straightforward, right? But there is some complexity. Got to think carefully about rounding rules. How many decimal places are we rounding to? Different currencies have different rounding rules. Secondly, how are we doing this currency conversion? Are we multiplying or are we dividing? You know, I always have to think very, very carefully about this to make sure I get it the right way round. And, you know, particularly if you mostly deal with currencies with similar values, things like euros, pounds, US dollars, which have a similar value, if you multiply when you should have divided or the other way, it's not always immediately apparent. You need some good thorough testing to make sure you get it the right way around. So it would be good to have standardize this, create a function to do that. So we can do that. We can create a PLSQL function, which does the calculation, returns the result, using our SQL statement like that, and job's great, right? Well, that is until you come to actually execute this query. What happens? It's suddenly an awful lot slower than just putting that expression directly in the where clause. So why is this? Well, there's a couple of key reasons. Firstly, and most importantly, we now have a context switch. So we've got the SQL engine and the PLSQL engine, and they are different things. Your SQL statement calls a PLSQL function. It's got to do a context switch from the SQL engine to the PLSQL engine, calculate the result, pass it back again. Now, while that overhead is really tiny, it's quite small, if you do it lots and lots and lots, it really adds up and can really slow your statements down. So that's one problem, context switching. The second problem is that function is a black box to the optimizer. This makes it harder to know things like how many rows does it think we're going to get back from the table, and harder for the optimizer to use indexes on those columns. So both of these things combine to make it more likely you're going to end up with much slower SQL statements. Now, you can address these to some extent. We could create a function-based index over that PLSQL function, but this doesn't avoid the problem entirely. Sometimes a full table scan is the fastest way to get the data, and the function-based index just isn't going to help us at all here. So we can then do some things in the function itself. We have this pragma UDF, which we introduced in 12C, which this lowers the cost of that context switch. Doesn't remove it entirely, but it can make it faster and improve things slightly. So both of these things can help, but they both have limits, and there's situations where they just don't necessarily help at all. It'd be nice if we could have something which just improve things across the board when calling PLSQL from SQL. Good news is we do now at last have that, SQL Macros. So what these do is they return a SQL expression. And at parse time, when parsing your SQL statement, the database resolves that expression and makes it part of the SQL statement. So what are these macros? Well, they come in two types, table and scalar. So table macros are ones that exist in the from clause. So you use those instead of a real table or a view or a pipeline table function, that kind of thing. They belong in the from clause. Scalar macros are ones you can use basically everywhere else in your SQL statement. Everywhere else it's legal to use a PLSQL function. So the select clause, the where clause, group by, order by, so on and so forth. I'm going to be focusing on scalar macros for the rest of this, for the next few slides, partly because I've talked about table macros a lot in the past, but also they're the only ones that are specific to 21C. So this whole feature was originally slated to be 21C only. Table macros have been backported to 19C, so you can use those today if you're on 19C. Scalar macros are only in 21C. So how do we actually write one? Well, we've got our function and we'll have that same expression, but we are now going to return a string, which is a scalar SQL macro. Notice we have a SQL macro scalar clause there. And the key thing here is what we are doing is returning a string, okay? And this is going to become part of the final SQL statement. So how does this help? How does the database resolve this? Well, what it does is when parsing that statement, it looks at the actual values you pass for the parameters, looks for those in the string, and essentially just does a find and replace those. So the text of those parameters become the actual values that are in the SQL statement. And then when running the SQL statement, the function essentially doesn't exist, okay? So let's run through some examples. I think it really helps to see some examples with this one. Let's say we call this function with values 1, 2, 3, 4. Well, hopefully fairly obviously, what we get in the result in is just those values 1, 2, 3, 4 are part of the final SQL statement. So that will literally appear in your where clause. So what about if we pass in some table columns? So we've shortened the names here a bit just so they fit on the slide, but we've got quantity, price, and rate. Well, again, those columns will become part of the final SQL statement that actually gets executed. Now, the interesting thing, or perhaps slightly more interesting thing, is what about bind variables and functions? What happens with those? Well, again, the database doesn't peek at the bind variable. It does not execute the function. Literally, the name of the function and a bind variable become part of the final SQL statement, right? So the database resolves that, does a find and replace of those, and that is the SQL statement that is executed. That expression that was shown on the right here is what would be in your where clause. So what this means is, if we've got this SQL macro in our where clause, database resolves it at parse time and was like, when actually running and executing the function, it doesn't exist because we've resolved it down to those SQL those expressions. So what does that mean? Well, it means there's no context switch. So we don't have the PLSQL to SQL context switch. Can be a big, big saving. Secondly, the optimizer can get more visibility of what those expressions are. This can help it use indexes and come up with better row estimates. It's not always going to help, but it does make it easier than that black box of a PLSQL function. So, sounds great, right? Sounds great. We can create these functions, make these things that are reusable in SQL and avoid the context switch. So some of you at this point are probably thinking, well, why don't we just make all of our existing PLSQL functions into macros? That's what we should do, right? Well, there is still a little gotcha or something to be aware of. And that is if you call these SQL macros in PLSQL, right? So this substitution, this resolving, only happens when you call them in SQL. If you call it in PLSQL, you just get the string back, okay? So you don't get the resolved expression, you just get literally the string back. So you've still got a bit of a decision to make here. If you've got functions that you call only in SQL, you can make macros and you're fine. If you call them in SQL and PLSQL, you've got to think about how you want to handle this. And you might have to create two versions of them, one which is a macro, one which is a normal function. So still some thinking to do a little bit about that. All right, then, let's move on a bit further and talk about another really exciting topic, full of the most exciting things today, auditing. So it's fairly regular for companies to be audited, and invoices are a key thing that auditors tend to look at. They often want to know who has changed them, when have they changed them, how have they changed them, because they're looking for things, people doing something dodgy. For example, let's say we're issuing an invoice for, someone's issued an invoice for 100 Swiss francs, got that money from the customer, and then after the fact, changed it to a lower value, 80 Swiss francs, and then just taken that 20 difference, those 20 francs, and pocketed the difference, right? The auditors really look out for that kind of thing and see if people have been cooking the books or doing something suspicious like that. And one way to prevent that happening is to stop people from being able to edit invoices. Just say, once it's created, you cannot change it, right? You have to issue a correction, a credit note, if there's a mistake in it. There's a very common requirement. So how do we ensure this in the database? Well, we can revoke, update, and delete from the invoices from the table from all users. But if you connect as the schema owner, you've always got full permissions on your own objects. So if you connect as the user that owns the table, you can still do whatever the heck you like with it. So to protect even further, you probably want to create a trigger on there, which if anyone tries to update or delete, it will just raise an exception and stop the whole thing in its tracks. So this is good, and this helps from, like, I don't know, casual attacks. You know, someone in sales or marketing who's trying to fiddle the books in some way or another. This will stop them, that kind of basic casual dodgy dealing. Someone who's a bit more clued up and really knows what they're doing, and particularly if they've got help from the IT support team, can actually do things like disable this trigger, re-grant access, fiddle the invoices in a way they weren't supposed to, and then just re-enable or put everything back how it was before. And this can be hard to spot. This is why it's really useful to have auditing enabled to track down if someone has done something a little bit suspicious like this. But the point here, it is still possible. It'd be good to stop people being able to change invoices at all. You can never update them. So how can we do that? Well, in 21C, we've added a feature which allows you to do that, and that is blockchain tables. Now, before we talk about how you actually make blockchain tables, some of you at this point are probably like, I'm sure you've all heard of blockchain at this point, but you may not know what it actually is, or what is blockchain all about. And actually, the concept's pretty straightforward. If we strip away all the cryptocurrency Bitcoin nonsense, the basic concept is pretty simple. Basically, what you do is you've got some data, and you store with that a hash of that data and the hash of the previous data in the chain. So when they're talking about blockchain, we're saying each unit of data is a block, and so you've got these blocks which form this chain of hashes. An Oracle database, or databases generally, if we're talking about these blockchains, what we're saying is we've got some row data. You've got your columns, you'll create a hash, concatenate them together, hash that data, and add in the hash of the previous row in the chain, okay? So what this then means is if anyone were to edit any of those columns, it's very easy to then detect that. The hash will never match. If I try and edit row 2, not only means the hash for row 2 is now out of sync, but in order to correct that, I also need to change the hash after it, and the hash after it, and the hash after it. So it's very easy to detect if someone has fiddled with or is trying to fiddle with the data, and it's very hard for an attacker to get in and actually change all the hashes in all in one go, because we have this chain ongoing linking in things together. And we've kind of implemented this in the background for you when you create blockchain tables. So how do you do it? Well, pretty straightforwardly, you have the create blockchain table clause. But there are 3 mandatory clauses when you create them. And these are ones you will want to pay very, very close attention to what you set the values to. So the first one is the no drop clause. So what I'm saying here is 28 days idle. That means I have to wait 4 weeks after the last row was inserted before I can drop this table, okay? So if you are playing around with this feature or testing it out, you want to make sure you want to set this to a pretty low value, 0 or a couple of days or something. Or you can find yourself with a whole bunch of tables that you can't drop. You can also make it so you can't drop the table at all as well. So be careful what you set this value to, particularly when you're testing or you're doing things like continuous integration, because you can end up with a whole bunch of tables you can't remove. So we've got the no drop clause. Next is the deletion clause. So we can insert the data, but we can also restrict when people are able to delete stuff. Now with invoices, things like invoices, financial data, you want to keep it for a long time, but not forever. After 7 years, you want to be able to purge off old historical records and archive it and get rid of it. So we can do that with the no delete clause. So what that means is we have to wait 366 days, a year, before we can delete a row, okay? So that's not any deletion, that's on a row specific level. The drop clause applies to any insert. Finally, there's just a hashing clause, and that specifies the algorithm that the database uses for creating the blockchain. So we've specified those clauses, and we've defined how and when we can drop or delete, or whether we can do it. But whatever you set those to, whenever you try and update a row, you will get an error. You can never update the row. You can insert deletion dependent on that clause, but you can never update it. Something that'll make the auditors nice and happy. So we've got blockchain table. We've also added a slight modification to this, immutable tables. So these are very similar, say immutable rather than blockchain. Notice we don't have the hashing clause. That's because it's an insert only table. We don't compute the blockchain for it. So what's the difference between these immutable and blockchain tables? Well, with both of them, you cannot change the data. You can't update it. You can insert it. You might be able to delete it depending on what you set that clause to, but you can never update it. The key difference between them comes down to computing that blockchain. So immutable does not do that. That means it uses less storage and it's faster to insert because it doesn't have to do that hashing. A lot of the times you just want, if you want insert only tables, immutable tables are what you are looking for. Blockchain tables, on the other hand, because you've got that full history of chain of data, it's much, you've got that full validation and can say that, yeah, nobody has changed this, and you can send that to auditors and so on. Look, it's absolutely secure. So most of the time you probably want immutable tables. Some of the time you might want blockchain tables for absolute belt and braces approach. Now, one final little thing to be aware of this. Some of you may have noticed the version numbers down the bottom right. So these were, again, another feature that was slated for 21C, but has been backported. Blockchain has been backported to 1910. Immutable tables actually are not yet available in 21C. Okay, they are currently only backported to 1911. They will be in 21C soon. All right then, so that's those tables. But if you look closely at this, you say you can't change the data or the structure. So we can't update it. But that also means if we try and alter the table to add or remove columns, you also cannot do that. You cannot change the columns in the table. Now, at this point, some of you might be panicking a little bit and going, hang on a second, what if I need to add some more attributes to the table, right? You know, I can't think 5, 10 years down the line, will we need to add some new columns to the table? How can we get around this? Well, one way to do that is to store the data as JSON. You can either store the whole invoice as JSON, or you could just have an optional JSON column to store, you know, future-proof yourself. That's a whole, which of those you do is a whole debate for another day. But what you can do is have a JSON column. And notice I've got our invoice JSON. The data type here is a JSON data type. So this is optimized for storing JSON data. If you've got an application which stores large JSON objects directly in the database, I'd really suggest you check this out. And this is something that definitely won't get backported, right? So if you work with JSON a lot stored in the database, this might be something you want to upgrade for. Okay, we're getting this kind of on the hour, but I've got just a few final things to say. I'll get them finished in the next couple of minutes. All right, so we can insert our invoices, and we're going to have an array of invoices. So we've got the individual items as an array within that. And that brings an interesting question. What if we want to find all the invoices which contain a particular product? So within that array somewhere. Well, you could try and write a query a bit like this, right? It's like do an in list. I mean, this is just crackers. The right way to do it is a JSON exists, which is not too obvious. It uses a JSON search expression to find the values. Again, I don't have time to go into the details of this, just other than, you know, if you do work with JSON a lot, get comfortable with these. So that's nice, but an interesting question is, how do we then index this? How do we ensure this uses an index? How do we get the values out of that array? Well, again, in 21C, we've now got a new index type, a multi-value index. So this is specifically for items within a JSON array stored in a particular column. And if we create that index and do that JSON exists query on the previous table, we'll see in the plan, you've got this range scan, and you type a range scan, and it's called multi-value. So that's how you know you've used that type of index as opposed to any other index you might have available. All righty then, we've kind of covered what I talked about what I had to cover today. And so you're like this point, kind of like, you know, I've covered a fair bit of stuff, even in just half an hour. Like, how can I remember all this? Or, you know, and, you know, this is just a fraction of the stuff that's in 21C as well. There's a whole bunch of other cool stuff I would love to talk about. If you want to see what's in what release and when, I really recommend you check out the database features and licensing application. So apex.oracle.com/database-features. You can see which version they're in. And also, thing I'm sure interests a lot of you, the licensing thing as well, which version edition of Oracle database these features are available in. Alrighty then, that is what I had to say. I really hope you enjoyed this. More importantly, I hope you learned something. Here's some links if you want to learn a bit more about this stuff. I can hang around to answer some questions now. Okay, yeah, just if you've got questions, just put them in the Q&A, or you can put them in the chat.
Okay, thank you, Chris. We have no question until now. So if someone wants to ask a question, you can write it in the Q&A or just raise your hand.
Yeah, so, I mean, there was a fairly quick overview there. So I'm sure some of you will be like, you know, once you get into the details of these, find you've got more questions and more things you want to know. They say that if you want to know more about the PLSQL loops, like I say, I think there is a lot to those. That my blog post here goes into a lot of detail on them. And once you've started playing with them and gotten used to them, you're like, you're kind of like, oh, do I have to go back and like some older version of the database and start using those? If you don't want to ask a question now, you can always reach me on Ask Tom or Twitter and things, and I'll be happy to help or answer your questions in the future as well.
Chris, this is Clement speaking. I have a question.
Yeah, go on.
And because I tested a bit with blockchain tables, I also wrote a blog about it because if you do, if you insert lots of data, then during commit time, this may take time, right? Because it has to calculate the whole hashes through the lists you inserted. Now, the issue there is, or for me, was that, the default value of PCT3 of 10 is not appropriate for such type of tables, right? Because, you insert and then, lots of rows go into the block. And at the end, when you do the commit, it updates it and adds all the hash stuff, right? And produces masses of, row migrations. I mean, right? Is this something you think about in at Oracle, or?
That's a good point, actually. I wasn't aware of that. I can take that up internally. Yeah, that's not something I thought about, but it's a good point. You say you got a blog post which goes into detail about that?
Okay, no, that's fine. Thank you.
Yeah, but yeah, it's a good point, and it's something that maybe we could look at changing defaults on those, but I'd have to speak to developers on that.
Okay. If there are no other questions, thank you very much, Chris, for being with us. It was great to have you here, and maybe you will stay with us and see some other sessions, or
yeah. I'll hang around a bit
soon. Okay, great.
I need to get some coffee first.
Yeah, of course.
Okay, I'm stopping recording now.
Yeah.